Hello, welcome to Groundwork, a podcast from McLanahan Corporation to talk about key material processing topics. From agriculture to mining to material recycling, we'll discuss the best ways to process the raw materials that power the world, because if it's not grown, it's mined. Thanks for joining us. My name is Matthew Lear. I'm a regional sales manager at McLanahan. So I specialize in sand washing, applications washing, and classifying. I've been with McLanahan for about 11 years, actually about the same as Joel here, who's going to be my co-host today on our podcast.
Hi, guys. I'm Joel Walstrom, process engineer at McLanahan and lab manager for the last 3 or 4 years. I've been with this company for 11 years, the same as Matt. And yeah, we've been through quite a bit together. So, yeah, this is right up our alley on taking samples, and we really know how not to take samples just from experience.
Yeah, a lot of experience in that field.
Yeah.
So today's podcast is obviously going to talk about sampling. So we'll talk about A, what our lab does, and then B, we'll talk about how to take field samples, kind of finish up with how do you submit samples to the lab. So that's kind of the general gist of today's podcast. So to start it off, Joel, maybe you can run through kind of what our lab is and what it does and the capabilities we have and all that stuff.
McLanahan has a lab, so we can test the material and size the equipment, because we are an equipment manufacturer. So the lab really gives us the information that we need to accurately size equipment.
The lab is really like the first step, right, of any project that we work on. Like the first thing we do is analyze what the sample is, what material is coming in, what needs to be done with the material to make spec product. It all starts at the lab, and then it kind of carries on throughout the entire process. So it's one of the most vital parts of our business model, to be honest.
It's real life testing, but at a smaller scale. So the results that we get from our testing, that's what we use to select equipment.
What kind of tests do we do there, Joel? I know we ship samples. Like, people can send bulk samples in, small samples. We get everything from Gatorade bottles up to 55-gallon drums. How do you guys kind of process that stuff?
We have a dozen to 20 different tests, anything from dry to wet. We have everything from crushing all the way through, water tailings management.
So another thing we do a lot in the lab, Joel, is thickener and filter press testing. I know we do a lot of testing in-house before we size thickeners and filter presses, before we even quote them. We like to have a lot of that data done. Maybe touch a little bit about what we do for those kind of tests.
Yeah, so thickeners and filter presses, thickeners are really challenging, in our world, because the size analysis can be different from one sample to another. And then you get particle sizes less minus 20, even minus 10 microns down to 0. And it's you never know how it's going to react and what flocculant you're going to need. And it all ends up, what size thickener do you need? And it's something that could take a 20-foot thickener might need a 60-foot in a different application if you have some of those clays that you can't settle out. And as well as a filter press, you're thickening the mud and you're sending it to a filter press. But if that material behaves a certain way and it's in a particle size range where it's hard to dewater, then you might need 2 presses. Where another application, you might only need 1 or half of the size of 1. Where it's really, really important to do that kind of testing. So what we do is we do a standard size distribution with our row tap down to 400 mesh, 38 microns. And then we also have a Malvern master sizer, which we take that minus 400 mesh material, minus 38 microns, and we put it through the master sizer, which is a laser diffraction device that measures down to sub-micron particle size. Knowing that kind of gives us an indication of, okay, it's going to be hard or easy to settle, but it really gives us that data that we need to know. So we take that material, sometimes we make down our own samples from, a given sample, or a customer will send in, plant overflow, which is the tailings, which is what we're dealing with. And we'll have that size distribution that we can send to them. And then we start working through a settling test, and we do both static and dynamic settling tests. A static test, we pick a flocculant, find the one that works. We get them the customer the best flocculant, and the lowest charge, or the least cost that it will be to them, to get the material to settle out, and in the size thickener that we select. Dynamic testing is a really big deal too, because a static test is static. A thickener is continuous. So to do a dynamic test, which is a continuous test, to get, we do it for rise rate and, settled solids, percent solids in the mud. sometimes you get something to settle in a static, graduated cylinder, and then you go and do the same characteristics for the dynamic settling test, and it doesn't work. And then you have to reduce the flow rate a little bit, which, and in the end increases the size of the thickener. You could be stuck at that point out on site and you can't get it to work. It's like, what do we do now? So it really helps with that, especially with the finer clays and materials minus 20 microns.
That allows you to add dilution into the feed too, right? Which you can't really do in a static test, right? Like you can change the percent solids in the feed to dilute it, which can help settling characteristics.
Yep, you can change that. You can change the flow rate of the flocculant. You can change the percent solution in the flocculant. It's really it gets the name dynamic for a reason, but you can try anything really. And it also, like the hydrosizer, it's a clear tube where you can see what's going on, right? So you start getting flocks in the overflow, and I mean, to add to that, you push it to the point where it doesn't work. So you get the customer, the smallest thickener that they need, which costs less. Everything comes down to cost. So we also have the ability to pump directly out of the underflow of the dynamic settling unit into a bucket, and then we transfer the bucket over to our filter press, which we pump directly from the thickener underflow from the dynamic test into the press. So it's as close as you can get in the lab to real world examples.
So that kind of covers kind of what the lab capabilities are, what it kind of does. One thing I kind of want to switch over to a little bit is field sampling. So a lot of the samples, once we receive it, we do a lot of analysis on it, but those analysis are only so accurate depending on how well it's sampled in the field. So Joel, you and I have kind of seen all kinds of different types of sampling over the years, coming from just hanging a bucket over the end of a pipe and letting it overflow and messing up all the percent solids versus putting a Gatorade bottle in a stream and setting it downstream of the processing plant. So we've kind of seen a little bit of everything over the years. So I kind of wanted to touch a little bit on how we recommend to take field samples pertaining to specific kind of pieces of equipment. So the one thing, the most common samples we probably get in the lab, Joel, and you can chime in whenever you want, but we kind of get percent solids and gradations the most for like fines recovery applications, as well as thickeners and filter press sizings. So a good way to get a sample from that, from like say you have existing screw washer, is by getting a weir overflow sample. So obviously, most of you guys are pretty familiar with screw washers. They have long horizontal weirs, usually three sides, that has all the wastewater effluent comes from the screw and goes to a settling pond. So sometimes there's material in there we want to capture and put back into a product, or dewater it or thicken it before a settling pond. So we recommend to get a sample of that to ship to our lab to kind of be analyzed. So a good way to do that is to get like a Gatorade bottle that has like a larger opening on the top of it. And then basically you go along the weir as safely as possible and try to swipe the slurry and fill that Gatorade bottle up. What you don't want to do is let the Gatorade bottle overflow, because when you overflow, what it does is the solids get compacted in the bottle, but the water overflows. So you're essentially messing up the percent solids in that slurry. So you want to kind of swipe until the Gatorade bottle is full, and then you dump it in, say, a 1 gallon or a 5 gallon bucket. Go to the next couple feet, swipe it again until it's full, dump it in the bucket, kind of keep doing that until you get all the way around the weir. That's the most accurate way to get an overflow sample from a screw washer.
Yep, and also measuring the depth of the overflow coming off the back of the screw, off each side. So if you have different depths, right, or I guess all three sides are the same, width, but if you have a different depth, it's good to measure that. If you do, you take a separate sample, one for each side, if that's a possibility there, because yeah, you could be losing stuff out the back and not the sides, and then you raise it a little bit, and you're not losing anything anymore, right? So,
Yep. How many times have you seen where the side weirs are all the way up and the back weirs all the way down? So they have like 6 inches of flow in the back of the screw, and then half an inch on the sides. So obviously you're getting more material on that area than the other side. So being level and even is good rule of practice, but coming to sampling, you got to look at that as well. So you want to make sure the weirs are level and even before you grab the samples. So that's probably the most common sample to be gathered in the field. The other thing that we sample a lot is pump discharge, like feeding a cyclone, as well as effluent from a cyclone or the cyclone underflow. We do a lot of that style of equipment, so those kind of samples are good. A major breakthrough that I say we've kind of pioneered in the last probably 4 or 5 years is by adding sampling ports on the discharge spool pieces of our pumps. So coming off the pump, we'll have a steel rubber lined spool piece that has like an inch and a half ball valve on it. That's all rubber lined. And then it comes like a 2-inch hose that goes down that you can get a sample from. So basically, if the pump's running and it's all homogenized, you can just crack that ball valve, put it into a 5 gallon bucket, get a good sample, and that's an exact representative sample of what's feeding the cyclone or feeding the circuit or going to the pond. So that's kind of a new standardized feature that McLanahan's kind of, I would say, pioneered in the last few years. That's become kind of standard on all of our equipment. So having that sample port is a great way to get a feed sample going to a cyclone or pumping to a pond or something like that. So it's a good way to get those samples. If you don't have something like that, you can obviously tap, say you have HDPE pipe that's discharging to the pond. You can put a saddle valve on there with like a 1-inch ball valve and then tap that in and use that as the same principle as long as there's enough pressure pushing the slurry down the pipe. So those kind of things are pretty critical to get like a good representative sample. Whereas the olden days, the guys would just, shimmy out in the end of the pipe with a bucket and grab it, which is never recommended because A, it's unsafe. And you can see people falling in ponds and getting splashed. And then the worst part is they do all that work and effort and half the stuff flies out of the bucket. They don't even get a sample anyway. So it's like, save yourself a swim and sample the proper way, right? So Joel, maybe you could touch a little bit on the sample device we have now.
Yeah, well, to add to what you were saying too, if we're trying to evaluate a piece of equipment, say a cyclone, we have to know what the feed underflow and overflow is to evaluate it. Like there's no other way to do it. And if you don't have sample ports, then how are you going to get an overflow sample? And I've seen somebody try to grab an overflow sample from a UFR and took the bucket out of their hands and it ended up on the rakes and the thickener. So, having sample ports and good sample devices. Back to what you asked, there's it's from, I believe, Cole Palmer, but there's an actual sampling device that they make that it looks kind of like a water pitcher with a steel rod that screws into it. And it has different attachments, lids and all, many different things. But for example, our pilot plant in the lab, we bought one for that, and that's how we take samples with it. And without that, the Gatorade bottle is your next best choice because of the wide mouth on it. But it's a little messy. But
sometimes it's your only option.
Yes, yeah. And back to the fact of how to take the samples, like when you get a cyclone underflow sample, you want to always make sure that you take the cross section of it. So you swipe across, and then you swipe back across, and then you swipe each way, because the sand doesn't have a brain or its own mind. It just goes wherever the water takes it, right? So some of it can get to one side or the other, or
Yep. And it's a lot easier just to kind of hold the bottle on the outside of the stream from the cyclone underflow, right? Because you don't have to get as messy and you can keep your shirt nice and clean, but you're only getting a part of the stream. So it's got to be a full representative sample. So when it comes to kind of representative samples, it's kind of up to the customer to tell us what the samples the feed gradations are going to look like, right? So typically we'll do borehole data on greenfield sites where they'll maybe drill hundreds of holes, 100 holes, let's just say, and they'll go down 50 to 100 feet. And every 10 feet, they're doing a sample of what that looks like. So they'll do a particle size distribution on every 10 foot of that borehole, and then they'll do that times whatever, 50 to 100 other boreholes. So sometimes the data we get is so large that we have to compile it, look at like a min and a max and an average. So we could do that, but typically the customer does a lot of that up beforehand before they send it to us for application design. But if needed, we can kind of look at the whole raw data and kind of help them compile it and work as a team to kind of figure that out.
Yeah, so you just send them design size for worst case.
Yep. Yeah, and I think that's one thing people forget is they think that one gradation is the end-all be-all of a plant's design and what its throughput should be, and it's not the case. I mean, a sample is literally a snapshot of one moment in time that plant's going to see that specific gradation, right? So you got to that's why we try to look at like the best case, the worst case, and kind of maybe an average in between. But a lot of plant designs will be, some other people design them based off an average, but that average doesn't include the deviation in between all those different samples, right? So that's why we look at like a min and a max and then an average to kind of give the customer on the models the tonnage yields based off those different gradations that the plant could see, even from 6 a.m. when the fire's up to say 10 a.m. when the feed's completely different, right? It all changes. So the more information we have, the more data we have, the more accurate and more efficient our plants will be. But so those are kind of the simple kind of sampling things. Another thing that was sampled pretty frequently in the field is when it comes to sand classifying tanks, discharge coming out of the flumes that would be used for like concrete sand, mason sand, non-spec sand, class 2, whatever you're making. So people like to tend to get good samples of what's coming out of each station in the sand classifying tank. And that's another way that you can kind of tell what a feed stream would look like or what you can kind of play with your percentages on the sand tank to kind of make a spec product. So we typically recommend the same kind of principle. Get a large open container that has like a large Gatorade bottle with a wide mouth on it that you can kind of swipe when the valve discharges, you kind of swipe it through that stream and try to get all the way through it until it's full, but not letting it overflow. And then that's a good way to kind of get a sample of each station. So with that, then, Joel, we can run models and simulations to say, hey, 10% of this station, 20% of this station, 5% of the next station. You can kind of mix that to kind of make a specialty product or a simple concrete sand or mason sand or something like that. So that kind of sampling is pretty critical in the field, as well as for just kind of troubleshooting an existing plant.
Yep, and we hope we never have to do that, because taking those samples is not fun. It's the opposite of fun.
It's not easy, yeah.
No, it's not easy. So you hope that it just works out the way that you think it's going to. You don't have to, but yeah, there's really no other way.
Exactly. So those are kind of the simple kind of field sampling procedures we can do. One thing we wanted to touch on to finish up, Joel, was kind of how do we send a sample to the lab? What's required? What kind of material? Do we need any safety paperwork? That kind of stuff. So I don't know if you mind touching on those details before we kind of wrap up.
Yeah, we want to first of all get a bucket that has a good sealable lid on it, so it doesn't leak in the process. Because if it leaks out, then it's no good. We send it back or dump it out, depending on what it is. We cannot accept the sample in the lab, or I guess maybe we'll accept the delivery, but we cannot open a sample without an STS sheet.
Safe data sheet, right?
In the lab, like, we need to have the buckets need labeled, right? So we're getting samples from all over the world. If the bucket doesn't have a label on it, we don't know what it is, then it's kind of, we just put it in a pile until somebody claims it or we figure out where it came from.
Needs to be properly labeled.
Right. And then also the request form and the lab forms that are sent to the customer, those need to be attached to the bucket as well. That way we know where it came from, and then we have details on it from you or another salesman or anybody else in the company. We have the details. It takes less time to track things down, and then we can just get working on it as soon as we're ready, instead of trying to play back and forth, phone tag and all that, which we do a lot of. So
what about shipping a bottle in a box? You can talk about that a little bit, and how we don't recommend to do that.
We do not recommend doing that. We recommend, you just think about how the truck driver, how would you handle things? Like, right, they throw boxes. You have to have it secured in there. If you're sending up, water in a 5-gallon bucket, right? Because it's not invincible. So the best way to do it is to put it on a skid and strap it down to it, or any way that that it's not going to spill on the way in. And also, number one, make sure there isn't a sticker on the bottom of the lid, because
that's a big one.
Obviously, you put that in there with water, it disintegrates into the sample, and then it's no good.
It's hard to sieve that out.
Yeah. So
yeah, I couldn't tell you how many times we've received samples, and Joel, you can attest how it's a Gatorade bottle in a box, and by the time it gets here, it's nothing but sand, because all the Gatorade bottles have been thrown so much that it's spilled out, and we have to you got to sample it again and send it back. So another week or 2 weeks lost. So properly packaging the samples is critical. So that kind of wraps up about everything we wanted to talk about, I think. And Joel, unless there's something else you want to add.
There's no such thing as too much information. So whenever you're filling out your sample sheet, the more information we have, the more, the lab guys know what to do. We know what the end goal is. It makes it a little bit easier. The whole process move more smoothly.
No, we're a very detail-oriented company, so the more information we can get to design a plant was just a guarantee that it's going to work properly when we actually ship it. So that kind of wraps up our podcast. Appreciate everybody joining. Once again, thanks for listening to Groundwork, a McLanahan podcast. Be sure to subscribe on your favorite listening app for new episodes, and follow McLanahan on social media for more content. Thanks, everybody.